How are you? After I finish the chapters of differentiation and application and anything related to it, let's talk today about the opposite of integration, differentiation, sorry, which is called antiderivatives. What do you mean by that? If you remember, when we took the derivative of this, let's say we have x to the power 3. What was the derivative of it? The derivative of this was bringing the 3 and the power less by 1, right? Now, what we will do now, that we're going to go backward, all right? Taking this function, okay, and going backward, we call it antiderivative. Because at the beginning it was called derivative. So the antiderivative is supposed to get us where? To this one. This is the common sense. We start, we have destination, we want to go back, we go back to our original step. So how do we go from here to here? You notice that the two, what's happened from here, getting from here to there? What's really happened? We added to the power 1 and we divided by the power. And the 3 stays. Got it? So this will be x power 3 over 3, and there's a 3 originally, we don't touch it. So those will cancel out, and then we end up with the same thing. But in integration, there is a little bit thing we have to identify, something called with a constant, which we don't know what is it. Could be 1, 2, 3, 4. So we're always going to keep that symbol. So from now on, if I ask you to integrate, this is the signal or the sign of the integral sign. It's called an integral sign, all right? With respect to x, then you go back to this. Let's have another example. If you remember, also we had something like, let's say y equals, why should we always say y? Let's say f of x, and it's equal 5x to the power 3. What's the derivative of that? The derivative symbol is that, and we're going to bring the 3 down, remember, and the power minus 1. That's the usual thing. So the answer will be 15x to the power 2. This is applying the derivative. If I want to apply the antiderivative, sorry, we have another word for it. If we're going to integrate, it doesn't matter, they're the same, because integration is the opposite of differentiation. What do? We're going to go back and say the power will have one more over itself. Let's simplify this. 15 over 3 is 5, x cubed, oops, it's the same. But as I said before, always when we integrate, we add a constant that it will help us later on. All right? So this is the system of integration. If you remember what you've been doing in differentiation, if you remember the sine is cosine, the tan is secant squared, then everything is reversible. Okay? Let's have some examples to solid this idea, make it more solid. All right? Before I make more examples, just keep in mind this integration sign, or we call the integral, okay? In your notes it's called the integral sign, yes? Whatever the integrand over here, remember that was the derivative? With respect to x, it will get us where? It will bring us to the official or to the original function. So that's called the integral sign. This is called the integrand. And you must always put dot dx, which means you are integrating the function, whatever the function called, with respect to x. That one. All right? This is in general. Everything applies to that one. So, let's have a few examples. All right? Example 1. What is the integration of x to the power 7? This is not the right way to write it down. I must put dx. So what is integration of x squared with dx? We bring this x power 1 and divide it by 8 plus c. So at the end of it, x power 8 over 8, you may write it like this. It doesn't matter how you do it. Okay? How about if I have another little number here? Let's have a constant over there. Suppose I have square root of 2x to the power 4. You know, a constant, it changed nothing. All right? So, I could leave it out if I want. As far as the variable is inside, and the variable is x, which I'm integrating that variable with respect to x. So simply, it's going to be x5 over 5. And don't forget the constant. All right? Clear? How about if I say 3 over x to the power 7 with respect to x? Like derivatives, we cannot differentiate that, integrate that, unless I take it up. Change the sign. No need to take it out, but we know that sequence is not unaffected. So keep it. What is minus 7 plus 1? Minus 6. So at the end of it, 3x minus 6 over minus 6 plus c. And my advice to you, simplify. And simplify means bring the negative to positive. Over 3 is 1, over 3 is minus 2. You can leave it like that, plus c. This is in simplest form. You must not maybe, you must, so be careful. How about if I give you something like that? Now, the root, or the square root, or the cubic root, is for both. How can I make it like that? Split them. From the basic thing you learn in Math 1, that this means like square root of AB. It's a square root of A times square root of B. All right? So square root of 5 times square root of x dx. This is the rule that you have to keep in mind. All right? And I should first take the power half. Once you do it this way, then you should have no problem in finishing up. Because the power is what? Half. And leave this alone. X power half means what? Plus 1. Half plus 1. Which is 3 over 2. Haha, over 3 over 2. Plus c. Correct? Always you add. In integration, you add to the power. In differentiation, you subtract from the power. 1. So at the end of it, square root of 5, x to the power 3 over 2. And guess what? 3 over 2 over this, it will come here. So that 2, when it's divided and divided, it comes there. Get used to this habit. Don't forget my little c. All right? Thank you. Well, how about if I go back to some basics? What is the derivative of 3? Integration of 3. Remember before, when you used to integrate, when you used to differentiate, when I used to tell you y equals x squared plus 1, you used to say what? 2x, a constant, 0. All right? And if it was here plus 3x, the x will be 3. Now we have the opposite. I'm giving you a number. It will go to this. If I give you power 1, it will go to that. If there is nothing, how would I know I go back there? Ta-da! That's why we say, must always say C. So this one is solved already. Look. C, 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 C. That one we took about it. But how about if it was only a number? Just think about it. When we differentiate the 3x, the x will go. Why? Because 3x power 1 minus 1, 0. X power 0 is 1. That's why we have a 3. Likewise now, what is the integration of 3? bring the x, don't forget the c. Simple. All right. Now, these are called zero level. I'm going to clean that. You can, by the way, you can stop it and pause your video, and at the end of it, go again and see what's going on. My advice, do it with your notes. The notes have the same style, but not the same question, so you can practice more. Number 6. How about this time if I say 5x to the power 3 minus 2x plus 7? If you write plus and minus, this is a combination of 3 functions, cubic, linear, constant. You've got to put this. Sometimes you forgot to put it, it's wrong, but stupid mistake. Okay? So, gentlemen, let's do them all together at once. What is the integration? We put equal. 5x cubed plus 1 is a 4 over 4 minus 2x power 2 over 2. Maybe you should remember that. Plus 7, it's going to go up 7x. And don't forget, okay, your third assessment will include questions like integration. So we will look at every single thing in the answer. If you have missing anything, you lose marks, so watch out. I can simplify this any further. Make your answer in descending order if you can, all right? Number 7, let's put some tricky stuff. Sometimes we like to put some tricky stuff. For example, what's the integration of x times y with respect to x? Now, you have to understand, who's the variable here? This is the variable. So anything x, you gotta apply the rule. Anything else, consider it a constant, all right? So, if you notice very well, the y is a constant. I can throw it out for a minute to see what's going on. Then, since the x is the variable, and leave the y as it is, plus c. So think of the y like 2, 5, square root of 2, square root of 5. Okay? Now people say, oh, I understand, that's easy. But how about this one? X, y, dy. Who's the variable here? I don't know, unless I look at this one. This will tell me I'm the variable. This is the variable. Forget about that. So leave that alone. And the y will be 1 power 1 plus 1 is 2 over 2 plus c. You can rewrite it nicely and beautifully if you wish. You don't like to have beautiful answer, it's up to you. All right, gentlemen? Many little basic things, we will forget about it. How about if I give you a number like that? Number 9. Z dw. Who's the variable? My variable, who is that? Put the red in the red. All right, and put the blue in the blue. Now my variable is the w. Anything here w? No. So that's a constant. So what's the answer for it? ZW. Remember that one? The 7 variable x, 7x. If it was 5, 5x. But if this was y, then you should say 7y. If that was w, then you should something whatever w plus c. Just to back up this question with something different or something close, zw5 dw. Now you can see the heck of it. Who is the variable? Is the w. So the z will stay, it's just a constant. And w5, because it's integrated with respect to w, then w6 over 6 plus c. All right, gentlemen? So, that's the basic rule of the power. All right? You could pause your video, not while cleaning, and then you can repeat that to make sure you know the basic. Please don't come next week, even though you have assignments, and you have quizzes, and you haven't reviewed that one. You've got to do it. Otherwise, you will be behind, and you will tell me, oh, sir, but I cannot, I have too many assignments, too many quizzes. What can we do? Now, let me go to the basic rule. If let's say number 1, all of that was called number 1. Let's call this now rule number 2. We all knew the derivative of sine x. Remember that one? What is it? Cosine. So, if I ask you, what is the integration of cosine x with respect to x? The answer is there. What is it? It is sine x. And don't forget, I always said plus c. You want to memorize that? It's up to you. If you remember derivatives, you have no problem with integration. Number 3. If you remember, what is that derivative of cosine x? What do you used to say? Yes, minus sine x. Now, if I'm going to ask you, what is the integration of sine x with respect to x? I didn't put minus. So when I go back there, I need to bring the minus over here. So it's a minus cosine x plus c. This confuses people because they just memorize. Remember, it's very killing if you don't remember that one. How about something you already know? The derivative of what? The tangent x. These we know by heart. So let's not say, I forgot about it. We can't. The integration of that is what? If you, sorry, what did I do? Oh, I remember, sorry. The derivative of this, it was what? Secant x. Anything missing? Yes, it's a square. Don't put the square here, not to the top in between, there. So if I want to integrate secant square x with respect to x, the answer is there already. The integration, this is derivative integration, is simply tangent. But don't forget plus c. And that's how you go. All right? You remember I developed this for you, derivatives by quotient rule. There are many other functions in trig. If those ones you see, you should know them by heart. If the next 3 ones I'm going to talk about, we haven't taken them in derivative, but if you see them, you can use your formula sheet if you have a quiz, or simply look at your notes when you solve it. We allow you to do that because if you were in the exam, we would have given you what? A formula sheet. What are these things? Number 4. Tell you the truth, I remember them because I have to. What is the derivative of secant, or the integration of secant x at dx? If you were asked to find the integration of secant, simply it's called secant x tan x plus c. This is the integration of the secant, not secant square. So that's going to be memorized. The good thing about it, you should know how to use them. For example, if I ask you 3 secant 7x dx, what is the integration of that? Simply, the 3 stays. The secant will be secant 7x times tangent 7x. But don't forget, what's the derivative of 7x? 7 divided by 7. That's something that you need to develop. What's the other ratio you have here? The cotangent. What is the integration of cotangent x with respect to dx? Simply, the cotangent, if you all can see it, it's written in my, it's here. Lovely. La hawla. The integration of cosecant or cotangent, minor cotangent, yes. Integration of, we don't have anything called cotangent. We have something here called cosecant square. We have secant here, sorry, that's supposed to be secant square. So what's the integration of secant square? It's tangent, we know it. So integration of secant square tangent. All right. Now, what's the integration of secant? Secant. Let's not confuse anybody. All right. Let me go back to this. Now, number 4. Let's repeat number 3 and 4. The integration of secant square, we know it's tangent because the derivative tangent secant square. This is okay, well known. We should have no problem, right? The second one, what is integration of cosecant square? Okay, we didn't take the derivative, but now the answer for this is minus cotangent x. I can find the derivative of cot, I can find out, but there's no problem. But you have to know how to use them only, don't memorize them. Suppose I gave you the integration of secant x times tangent x. Okay, secant x times tangent x. What is the derivative of that? Now we know what used to be this one. Now we do the opposite. What is integration of secant tangent? The integration of secant tangent is always secant x plus c. Last one, you wanted to find also, if you see it, the cosecant times cotangent. The cosecant times the cotangent with respect to x. So, what's the integration of that? It's a minus cosecant. These are very helpful if you were in an integration class. Oh, by the way, this will be provided to you if you've seen this in a quiz. Unfortunately, this will be shown to you in assignment 3. So you can use them and you know how to use them. You can use them anytime you want. But let's have some examples. But one last one before we see an example. What's the integration of? For example, let's say 5 to the power of x dx. That's something beautiful. It's very nice how to do that. Okay. And it's written in page what? This is the page you need to know. Page 4. Okay. And all of that is in page 4. The integration, these are all in page 4 of chapter AC. So there is no need to go around, just know how to use the rules. The integration of this, it's itself the same, but divided by len 5. And don't forget the plus c. Maybe some people will say, I can memorize this, I can use it, but sometimes I get mixed up here. Let me show you something called, you've taken in the chapter before that, which is called logarithmic differentiation. Let me keep this one here, play a little game with you. I hope you enjoy it. Remember when I asked you find the derivative of this by using logarithmic differentiation? We used to say what? Len y equals len 5x, and then x len 5. Remember that one? Now take the derivative of both sides, this over that, and the derivative of this is len 5. And I said, preferably if you wish to multiply that. Remember that one? That. What's y? Y was this, times len 5. So, ladies and gentlemen, if I ask you, what's the derivative of this? What would you say? You would have said, it's, the derivative of that is this. I can derive it by logarithmic differentiation. But guess what? If I ask what's the integration of that? If I took this one only, without this, when I go back, I have to take this and divide that. Ta-da! This is only showing you why. I can show you each one of those cosecant to secant, but we used to do them by derivative. Once we do the by derivative, but unfortunately, you don't have to worry about how to do it. All right? So the derivative, the integration of 5 to the power x is self divided by len 5. If it was here, for example, 7, then the integration of the power of x, it's 7 to the power of x over len 7. Okay, ladies and gentlemen? So that's called, in my belief, chapter 8, first part. Chapter 8, inshallah, we will do it in 3 parts. Today I can call this, if you want, definite integrals 1, then the next step is to do more practice about the algebra. Like, for example, how do we integrate something like that? How do we integrate something like this? How do we integrate if we have something down? I want to use algebra because I know some of us are weak in algebra. This is nothing new. Nothing new. Now, one last one before we leave these topics all for good. This was number 8. Now, number 9, it is something you already know. What's the integration e to the power 5x with respect to x? As you all know, it's itself. Remember, even in derivative, we always itself. And the derivative 5x, we put 5. Now, the integration of that, divided by 5. All right? So the rule of this, whenever you see e, you put it as it is, but don't forget, take the power. What power? This power has to be linear. Anything squared, no. The rule doesn't apply. Number 10, the last one. Remember the derivative of ln x? We used to say 1 over x. Remember? Ln x, derivative of 1 over x. How about, what's the integration of 1 over x? The integration of 1 over x, it's also ln x. It's the opposite. Derivative, go back. Plus c. So these are the rules. You should know this by heart. No need to derive this because you all know up till here. I tried to prove to you that the derivative of this is that. So the integration of this is this. But if I don't have this one here, I should put it down here. But some people say, what? Okay, forget about it. Don't make it a big fuss, please. Just remember, if you have 7 to the power of x, 8 to the power of x, then any constant other than e, then it's the same 7 over this. Actually, some of you will say, but sir, can't we just do it a different way? No. Try to know these basics, know these rules, because my second session is going to be about using the same thing, but mix them together. Put algebra in them, and that's where you can find out how good you are. Thank you very much, and next time we'll meet with the second part.